Hi there, this is David from the Technical University of Denmark, DTU. Welcome back. In this session, I'm going to talk about mapping. I find mapping as a fascinating area in epidemiology. We can say that it's part of we can call it geographical epidemiology if you want. Maps are very important. It's a very important visualization tool with regards to animal diseases, human diseases, or factors related to diseases. So this lecture belongs to the data management for epidemiological analysis. So let's have a look at what are the objectives of this lecture. The main objective is that you can create your own maps, what we call dot maps and choropleth maps, using QGIS software or R software. Both of them are free software, which can be downloaded for free, and R is an open source, and I think QGIS is as well. There is an exercise attached to this video. In the exercises where you are going to exercise and going to be guided how you can make your maps. So in this lecture, we will look at the fundamentals of how you can create your maps. It's very important as well that you can be able to explain the role of mapping as a visualization tool with regards to antimicrobial resistance, epidemiology, or health in general. So the plan is that we will first look at the importance of mapping as a tool for visualization. We will look at the history of mapping and how this has evolved until nowadays with modern technologies. So we will look at modern maps and on some concepts related to modern mapping. And we will look at what is what we need to make our maps, which are the data we need for making maps. So let's first look at this map. This is probably the first map in history related to what we call a disease map. It was made in the 1800s, and it was made in the US. And this map shows a small area where the cases of yellow fever were piling up. It was an outbreak of yellow fever in the US, in the East Coast. So take a moment to see this yellow fever map. What we can see in this map are the different colorations, the intensity of the color of the black color within these blocks of houses or areas in the US. The intensity of the dots represents the higher cases of yellow fever. So we can see that in the center there were more cases because there were the dots are very much close to each other compared to other parts of in this area that is presented. Think for a moment of the impact of this kind of maps had at that time. What was the role of this map for people in charge of the health in this area? Was this helpful? It certainly was. Perhaps it gave them an idea where they have to concentrate their efforts to contain this outbreak. So disease mapping is an important branch of epidemiology or geographical epidemiology. The other important branch of geographical epidemiology or epidemiology in general is clustering. So let's have a look at another map. This is probably the most famous map in epidemiology. It shows what it was a cholera outbreak in London in the 19th century. And this map was made by John Snow, who is considered to be the father of the epidemiology. At John Snow's times, there was this theory called the miasma theory. This theory was very against the hypothesis of John Snow. John Snow believed that the cholera was caused by water contaminated. And the miasma theory was that the cholera cases were caused by the pollutant, by the air. So there was something in the air which was causing the presence of cholera in people. So what John Snow did in this disease map, a dot map, where he registered all the cases of cholera, all the fatal cases of cholera were registered and they were depicted in this map showing where they lived. The other important aspect that John Snow showed in his map was the location of the water pumps. So in Broad Street, as you can see, there is a high concentration of dots. So a lot of the cases were concentrated in this area where there was this water pump. So we can say that there was some kind of clustering around this water pump. So this map helped John Snow to prove his hypothesis that the water was a cause of cholera in London in the 19th century. So how is that maps are now made in nowadays? Well, John Snow made his map by hand, but now we use what is called geographical information systems. So geographical information systems help us to obtain spatial and geographical information, and with the aid of our computers, we can make maps quite easily. So in order to make our maps, we usually need what is called a health variable or a factor related to a health. And then we need our geographical data or spatial data. This information has to be merged so we can plot it, we can make maps. So what I meant with health variables, we can think about water, the quality of water, just like John Snow did. Or we can think about a special superbug or any other microorganism we are interested. And we can also think about factors related to health issues such as population, human density, environmental exposure, and many other things like presence of diseases. So when we talk about points, we usually we're referring about latitude and longitude coordinates. So we can locate an exact point where, for instance, a case was registered. And we can talk about a geographical area where we usually talk about this in the geographic as a polygons, where we can determine variables by larger areas such as continents, countries, or a village, or even smaller areas. So with the modernization of our societies and the technologies, we can now have interactive maps where we can play with different variables and see how this information helps us to get some better understanding of an issue that we are interested. One of these interactive maps that you can look at is found in this web address that you can see here in red. Let's have a look at that website for a moment. So we can see in this map the presence of multi-drug resistant tuberculosis without extensive drug resistance in both sexes. And we can see this is what is called a chloropet map, where we can get information when we hover over different countries. We can see, for instance, that the hot focus of this problem is now in southern Africa. Interactive maps also allow us to change different variables in this left menu. You can play with them, and so it's quite a neat tool. All these things related to mapping, I think it's just fascinating, and certainly it isn't a great tool when planning for improvement of health or trying to control a factor related to a disease. So to make our maps, we need some information. So the first thing will be to look at what we want to put to place in our map, define the problem. We're interested in a certain disease or a certain factor. So when we will define that, then we can start set up, in this case, our computer, and obtain the data we need, merge this data, and then make our map. Let's say we are interested to finding out surveillance system partners in Ghana. In this case, I'm referring to hospitals as a source of information for antimicrobial resistance surveillance. We want to plot them. We want to find out where they are. So what we need is to set up our computer in R. That means that we need to install some packages, and then we need to obtain some spatial information about the health facilities. So we do that with by looking at this web address, and then we get our information in our computer. And this is the information we are going to plot. So we get the coordinates, which is latitude and longitude, and the ownership of the hospitals, which is by the government. And so we make our map. This is a dot map showing the different locations of the hospitals. And it's quite of a neat map because it's also interactive, where you can zoom and zoom out, zoom in and zoom out. And you can also play with different projections such as this, or this, or this. Another neat map we need often is called color palette maps. And I have an example of Klebsiella pneumonia in Europe. And so we need to obtain our polygons. This is the geographical information, and we can obtain this with some packages in R, and this function will help us to obtain information, the polygons of Europe. And then we need to obtain the data we want to plot. In this case, we are interested in resistance isolates of Klebsiella pneumonia in Europe. And so we get our information in our computer. We will have the microbe we are interested, and we also get the year in which this isolate was obtained and in which country. And we obtain how many we got and whether it was antimicrobial susceptibility testing category. And so we merge our data, and what we are merging is the information, geographical information, together with the information about the microbe we are interested. So when it's finally merged, we can make our plot. So in this map called color map, is showing us the number of resistance isolates registered in 2019 in different countries of Europe. And in we have the legend here. So the greater number of cases, the isolates registered were probably here in Italy. So this is where the more number of isolates are found within Europe, which is quite of a neat way to get a quick impression of a particular issue related to antimicrobial resistance or health we are interested in looking at. So in this lecture, we already saw about the importance of mapping. We saw the history of the first maps ever made in our history. And we saw about dots maps, chloroplet maps, and we saw what are the steps to obtain our maps. So there is an exercise and a tutorial attached to this video that you should follow in order to be able to create your own maps.